Welcome to our lesson on derivatives and dynamics. In this session, we'll explore velocity and acceleration and how they help us understand motion. Let's dive in. In motion analysis, we use three main functions. First, the position function, denoted as s of t, tells us where the object is located at a given time t. Second, the velocity function, written as v of t, describes the speed and direction of the object. It is the derivative of the position function. Lastly, acceleration, represented as a of t, measures how velocity changes over time. It is the derivative of the velocity function or the second derivative of position. Velocity gives us important insights about an object's motion. If the velocity function is positive, the object is moving forward or upward. If the velocity is negative, the object moves backward or downward. When the velocity is zero, the object is momentarily at rest before changing direction. Acceleration helps us understand whether an object is speeding up or slowing down. If acceleration and velocity have the same sign, meaning both are positive or both are negative, then the object is speeding up. However, if acceleration and velocity have opposite signs, the object is slowing down. Let's apply these concepts to an example. Suppose we have a position function given by t cubed minus 6 times t squared plus 9 times t. Our goal is to find the velocity and acceleration functions and analyze the motion of the object. To find velocity, we take the derivative of the position function. This gives us 3 times t squared minus 12 times t plus 9. Now, let's determine when the object is at rest. We set velocity equal to 0 and solve for t. This results in two values, t equals 1 and t equals 3. This means the object stops moving at these times before changing direction. Next, we find acceleration by taking the derivative of the velocity function. This gives us 6 times t minus 12. To determine when acceleration changes, we set it equal to 0 and solve for t, giving us t equals 2. To analyze the motion, we compare the signs of velocity and acceleration. If they match, the object is speeding up. If they are opposite, the object is slowing down. We describe motion with three functions. Position, written as s of t, tells us where the object is. Velocity, written as v of t, is the derivative of position and shows speed and direction. Acceleration, written as a of t, is the derivative of velocity and tells us how velocity changes. For this example, the position function is s of t equals t cubed minus 6t squared plus 9t. Taking the derivative gives the velocity function, v of t equals 3t squared minus 12t plus 9. Differentiating again gives the acceleration function, a of t equals 6t minus 12. In the graph, the red point moves along the curve. The blue tangent line represents velocity. When velocity is positive, the object moves forward. When it is negative, it moves backward. The object stops when velocity is 0. The red arrow represents acceleration. It points in the direction of velocity change. If velocity and acceleration have the same sign, the object speeds up. If they have opposite signs, it slows down. We also add a blue velocity arrow parallel to the tangent line and a red acceleration arrow parallel to the acceleration line. These vectors show how motion changes. Now, try it yourself. Use the link below to move the time slider and observe velocity and acceleration in action. Thanks for watching.